Let's have a look now at another method of doing quadratic equations called the K method, where we're going to use substitution. So the big question is, when do we use the K method? Well, if we look at this and we think about what we've already learned from quadratic equations that have a denominator, if we were to multiply each term by this denominator, we do end up here with an x to the power of 4, and that's going to be very awkward. So that's the one way of spotting it. The other way of spotting it is we have an x squared plus 2x in the numerator here, because remember that's over 1, and we have the same thing in the denominator, and that's another way of spotting when to use the K method. So what we're going to do is we're going to literally substitute part of this equation with K, and that's why it's also known as the substitution method. So I'm going to say what I'm going to do, and I'm going to let this part of the equation, this expression from the equation, be equal to K. So in other words, wherever I see x squared plus 2x, I'm going to say K instead. So that whole thing there is going to become K. Then I've got minus 3 in the numerator. And then if I look at my denominator, x squared plus 2x, it's exactly that. So in its place, I'm going to write K. And then I end off with what I've got, equals 2. So just to go through that again, the important thing here is that you have to decide what you are going to set equal to K. And it's normally an x squared and an x term, in other words, two terms, but they have to be repeated somewhere in the equation. And here we can see the repetition. So wherever I see that, I write K minus 3 in the numerator, K equals 2. Now I'm going to solve the equation for K. So I'm back to an equation that's got a denominator, and I need to eliminate the denominator, and I do that by multiplying through by the LCD. Well, I don't have to worry about an LCD here because there's just the one denominator. So multiplying this term by K, I'll end up with K squared. When I multiply this term by K, they'll cancel, so I'm just left with 3. That doesn't have a denominator, so the K can't cancel with anything, so I have 2K. Now I can see that it's a quadratic trinomial because it's got a K squared. I need to regroup everything nicely onto the left-hand side in the correct order and set the right-hand side equal to 0. So K squared, then I need my K term next. It's coming across the equal sign, so it's minus 3 equals 0. So now I'm going to solve for K. So factors of 3 that can give me 2, 3 times 1, and 3 and 1 can give me 2. So I've got K and 3, K and 1. The signs in the brackets are different, and the biggest combination is negative. So my biggest combination is the inners, so that has a negative, and that has a positive. Right, so what we're going to do now is we're going to set out properly what the next step would be. It would be that either this bracket is equal to 0 or that bracket is equal to 0. So let's write exactly that down. Either K minus 3 is equal to 0 or K plus 1 is equal to 0. And then it's at this point that you now go back to see what is K actually representing. K is representing that you chose right at the beginning. So now instead of writing K, I'm going to substitute back and put my X expression in. So instead of K, I've got X squared plus 2X. So that's instead of K, but I've still got minus 3 equals 0. The same thing over here. Instead of K, I'm going to write that. And then I still have plus 1 equals 0. So what's happened with the K method is when I've used K to work out a quadratic equation in K, then when I substitute the x's back in, I end up with 2 quadratic equations, which means I could get 2 answers here and 2 answers there. So I could end up with 4 answers. Let's see what's going to happen. So now I'm back to needing to factorize again. So my 2 brackets equal to 0. Factors of 3, 3 times 1, so the one bracket will say 3, the other one 1. The signs in the brackets are different, and the biggest combination is positive. So this one's positive, that one's negative. Factorizing this one. 1 times 1 is my only option, and 1 and 1 can give me 2. The signs in the brackets are the same, and they're both positive. So now if I go through each of these brackets to see what the values for x are going to be, I've got from this first bracket, x would be negative 3 to make the bracket equal to 0. Here, x would be 1 to make the bracket equal to 0. And then here I've got 2 brackets that are identical, which means I'm only going to get one solution from this because this was a perfect square trinomial. And so here I only have x equal to, what would make that bracket equal to 0? Negative 1. So there I have my three answers for x. As I say, it could have been 4 answers if those 2 had been different brackets. So that is how to use the K method, and I hope that everybody's shouting at me, because what haven't we done yet? And I've purposefully left it out to see if you are awake and remembering what I've said in the previous videos. Those of you who are saying we've got a denominator with variables in it, and as soon as we've got a denominator with variables, we need to have restrictions. So we need to say that x squared plus 2x could be factorized as x, taking out a common x, which will leave me with x plus 2. So either I can't have that being equal to 0, and I can't have that being equal to 0. So therefore, x itself may not be equal to 0, and the other thing that would make the bracket equal to 0 would be negative 2. So x also cannot be equal to negative 2. So even if you've forgotten to do your restrictions and you go all the way down and get your answer, check. If you had a denominator in the beginning, you need to do restrictions. So let's just check. Are my answers okay? Yes, neither of them are clashing with those. So those are definitely my answers. And that is how to do the K method with substitution.